All right. And share screen. Well, welcome back, everyone, to the second installment of the Microbit PD for Granite School District. My name is Andy Lindsay, and I'll be your presenter today. Let's see here. Folks, can you hear me? Thumbs up. All right. Okay. So, so basically, we left off last week right about, well, oh, pardon me. Okay, so quick review of last week and today. So we talked about the microbit kind of in a general sense, what's built into it, what it can do. We did a lot of work in the getting started area with the different platforms and the different languages. And then we tried just a couple of applications. So what we're going to do today to start out is we're going to try out a few more examples with the microbit. And during that time, I'm going to try to hit some of the points that are really important where students and sometimes teachers get stuck in loading code into the microbit and things like that. Actually, arcade.makecode.com, I was only going to mention in passing. And then we're going to talk about, first of all, make code curricula, then microbit.org in general, and then the parallax and the cyber.org curricula. And we'll look at where to find things in each of those categories. So to start the review, where we're going to go is the user guide, because that's going to allow us to find some examples that we can run to both experience each hardware feature of the microbit and at the same time try all the different different ways of opening an example script and loading it. So I need to do the chat to everyone. So this is the first link we're going to go to. And this is nicely sorted by device. Now, I'm going to leave the input and output devices overview to you because we'll look at each one of them and just talk about them as examples. So the first output device that we did yesterday was the LED matrix display. So we did a nice beating heart. And we also did buttons, but that's where I'm going to restart today, is just to use the buttons to select an emotion. So I'll give you the link to this when we get there. So there's an overview, and then we can go to either make code or Python. We'll be going to Python more as we go into the workshop. So I'll start in make code. So we'll open this in make code. And a quick reminder that it starts you with blocks, but you can also jump into either JavaScript or Python, and that there's also a debugging environment that you can use to step through a simulated program. So this one's pretty simple. All you got to do, and so then this time we'll do the most basic way of loading it, which is to download the hex file. And so it's basically now sitting in my downloads. And then when you unplug and replug, or many of you, it'll be just a first time for today, plug your Microbit. When you plug it in, a Explorer window, a file browser window, should come up with your Microbit and the files that it contains showing. And so what you can do is you can drag the hex file that you just downloaded and drop it into the Microbit. And once it's done loading, you will have options. So bear with me a second. I need to stop the screen share for a minute. Okay, so here we are. And here's the Microbit. And basically, I can press one button for a frown and another button for a smile. So that's the second piece of hardware now. So we've got our lights and our push buttons. And can you give me a thumbs up or down on if you all got that running on your Microbit already, or if I need to give you some time to get reconnected? Okay, that's what I thought. Let's see here. So let me see if I can get you that link, the emotion badge link. Okay, so there is the emotion badge link in the chat. All right, good job, Ben. Yeah, hey, we can place our votes like this from now on instead of thumbs up. But some of you may still be in this situation. So, all righty, looking good. Steve, Kurt, thank you, Steve. And let's see. Was that a thumbs up, Ed? Oh, no. Okay. I'm waiting. Don't worry.
Ed's audio troubles solved?
It doesn't, I'm not sure. I'll go ahead. I just went and asked him to unmute. So we'll see if he's got some audio output or not. Debbie, was that a thumbs up? Okay, excellent. All righty. So I'm reading through my chats right now. Okay, so Ed is working with Zoom support to get reconnected to audio. Sorry about that, Ed. All right, so now let's take a look at the next example. Oopsie. Shared the wrong screen. Share screen. Screen 2. There we go. Okay. So next, let's try the accelerometer. That's a fun one. Now, I don't want to do any of these because I've got more accelerometer stuff to show you later. So I'd like to just do the most simple one. So I'm going to explore Accelerometer Projects, and I'll paste you this link. Oh boy, where did my chat go? Okay, so this is the next link, or basically this is where I am. And the one we'll do is just the most simple form of dice. So I'm going to paste in that link address. Now notice that there's graphical dice also, so you can get a number from 1 to 6, or you can get what you would see on an actual physical die. And for this one, we'll do it in MakeCode 2. But this time, we'll go ahead and connect and use the web USB interface to load the code. And basically, the code just has an event handler here, which says on shake, show me the number, and then it has a pick a random block, and all you have to do is give it the range between 0 and 6. So implicitly, by the way, there is implicitly, it's kind of like it's inside a repeat forever loop. So it just keeps on, being ready so that when you shake the microbit, it will give you a new number. This time, like I said, we want to click the 3 dots next to download and select connect device. And then it'll give us a reminder of how to connect your device, which is basically that you want to have it connected to your computer. And then when you hit next, it's going to give you a list of microbits. We all only have 1 connected. Oh, pardon me. So it's saying, hey, look for, BBC microbit, CMIS DAP, or DAP link CMIS DAP as choices. Click that and select next, and it's going to be a pop-up. So when I hit next, I want to see a pop-up. Here it is. And for me, it says BBC microbit, CMIS DAP. And so now I am connected. And now this download button should really be a flash button, because when I flash it, or when I click download, it's going to load the program into my microbit. And then, so right now I have 4, and I'm going to shake it, and I get 1. Shake it again. It looks like a 5, 6, 2, 1. By the way, my screen is displaying to me backwards, so I don't know if this looks right to you guys or not. And I'm not sure whether I got the 5 or the 2 mixed up. I think that's a 5. Looking good. All right. Okay, so how are we doing? Everybody got it? Thumbs up, thumbs down? Okay, still have a thumbs down. We're gonna hang on this for a minute. Always feel free to unmute and say, hey, I'm stuck on step X, and I can go back and show you. Good deal. You all right there, Jerry?
Hey, Andy, is there a pause just by default programmed into this when you shake it?
There might be. That's a good question. Let me see if maybe the JavaScript or the Python version has. No. Okay, so that's an interesting question, though. I wonder if we can find out more by looking in this basic show number. Okay, there's the blocks. So I just right-clicked and selected help. And I'm skimming it, and off the top, I don't see a pause, but I agree with you. There should be a pause built in. And there probably is, given the way it behaves. Oh, you know what? It might be in the show number. It might be implicit because the show number presumably has a pause to give you enough time to read it. It has a default value. The interval right here, here it is. So you can, see if I can zoom in on this without crashing my computer. Okay, so in JavaScript and Python, they give you the choice of setting the interval. And there is a default interval. So you call it out in a number of seconds, but the documentation does not say what that default interval is. I will try to email everybody about that. Okay, zoom back out. Good question. And sorry, I don't know the answer off the top of my head. I can tell you a little bit more in the Python world, but let's see here. Okay, so there might be, there's probably some way of setting the show number in here, but I don't know off the top of my head where it is, but this is where the delay is so that you know, it doesn't pick 6 different numbers every time you shake it. All righty. So next thing I want to review is disconnecting, because we're going to move over to the Python editor. So we don't want to be connected here if we're going to try to connect the Microbit Education Foundation's Python editor. So what you want to do is click the 3 dots and select disconnect. And it will tell you how to unpair your microbit. So basically, you want to click on the little lock icon and then click the X next to the BBC microbit that appears in the drop-down menu, and then refresh your browser. Okay, so everybody heads up on this one. I'm going to try doing it for you. All right, so clicking on the lock next to the web address, finding the BBC microbit entry in the dropdown, and clicking the X next to it, and then refreshing the browser. So now I'm officially disconnected and no longer able to just upload a serial file. So let me know when you're all ready to go after that one. Cool, great. Again, it's the little lock next to your web address. You click it, there's a drop down. Now it's not visible, but the microbit should have shown in here. And you click the X next to it and refresh your browser. Okay, everybody got it? Thumbs up? Awesome. All right, next up, back to the features page. And I'm going to close the tabs to the right of the features page simply because I don't want too many tabs open. Otherwise, I might crash my computer. So the next one we're going to look at is the temperature sensor. But we're going to do that. So I'm back in Microbit Get Started, user guide, features in depth. I'll just paste it in again so you know where I'm at. Copy. And then it's telling me that I selected temperature sensor. So chat. Everyone, paste. Okay, so that's where I am, and there's a nice little video about temperature sensing. Every physical feature in the microbit has a nice video along with some examples. And so let's do the basic thermometer. And actually, I'd like to at least do Fahrenheit to show you that it would require probably some more calibration. So here is the Fahrenheit thermometer. What I just did was I right-clicked Explore Temperature Projects, and then you get more than these 3. You get all these guys, and it shows you what's selected. Like I have temperature sensor. You can simply use the left side interface. All right, so then we've got the temperature. So here is the Fahrenheit thermometer, which I'll also share with you. Paste. Okay, there it is. And this time, we're going to go to the Microbit Education Foundation Python editor. So instead of following open and make code, click Python up above, and then select open in Python. I'm going to try this in a new tab in case I get lost. Okay, so here is the Python version, and granted, there's also a make it code it version that has the block programming or the JavaScript or the Microsoft Python options. So here we are in the Python code, while true, meaning repeat what's below and indented from it forever. And then if at any point between the current check and the last time checking, button A was pressed, then display.scroll the temperature. And if you're wondering about any of those, all you have to do is hit help and select documentation. And then we could look for temperature in here. I'm going to come back to that because we're going to do something with that during Compass. But that would be where you would search for display.scroll or temperature, et cetera, et cetera. Okay, so you can do the same thing when you're not connected. You can download a hex file and then drag and drop it into your microbit, or you can connect over web USB and you get the same little select your BBC microbit. So I want everybody to do that. I want everybody to click connect at their Python editor. And are you guys okay? Are you all there? Thumbs up on that? Looking good, thank you. Okay. So once we're here and once we're connected, then it'll take a little bit longer to flash since we were just in the Microsoft world. It takes a while for the Python editor to reload a Python runtime, MicroPython runtime that's compatible with the microbit, with the python.microbit.org editor. So that's why this is taking a little longer, but the next code load is going to go very quickly. And I am trying to keep up with your chats, anyone, but if it seems like I didn't respond to you, please do just unmute yourself. Shout out, hey, Andy, and whatever else is needed.
Hey, Andy, so we were supposed to click on the flash button, right?
Oh, I didn't call that out, did I? Yeah, click on the flash button, and then it's going to take a long time the first time, maybe a whopping, I don't know, 20 seconds. Seems like forever. And then the next time it's going to go very quickly. Now, I'm going to switch out of screen share. Hopefully I'm currently larger than life for you all. Take a look at the back of your microbit. There is a chip. Okay, so this gold squiggly right here, that gold squiggly is an antenna, and then for the built-in radio, and then right next to that gold squiggly, it's difficult to see. Oh, there we are, is the main processor, and the temperature measuring device is in there. It's actually designed just to tell you the temperature of the processor. So it's not really medical grade by a long shot. Anyway, so we're looking for the largest flat chip on the back of the microbit, but don't touch it yet. Just hit A to get your temperature. So let's see, what am I? 28. I must not have chosen the Fahrenheit example. Yeah, it looks like
You got the Celsius. The Fahrenheit has when you push B, it converts it.
Oh, thank you. All right, so back to. All right, so I'm going to press B for the conversion. Yeah, I completely ran the wrong program. Let me see if I can.
Your code was looking a lot shorter than mine.
Yeah. Okay, so maybe everybody else got to the right spot. Let me try to catch up with you here. Okay, so Fahrenheit thermometer.
Got to the right spot, and then I second guessed myself and started over.
Oh
Now
no!
I gotta
Here,
get
let
back
me give you a direct link to this. I'll paste it in a second here. Okay, I think I got you the right link now. It did seem to take me to the right spot. And then click open in Python. I'll re-screen share, make sure we're good here. Okay, does everybody have code that looks like that? And if so, make sure you're connected. So it'll say disconnect and it'll show a little connected icon and then hit flash. And then stop share. All right, so hopefully if I press the B button now, okay, whoopsie. Okay, so it's about 84.5 degrees according to the microbit. That's a bit toasty. I would say it's more like 78 in here. And so, but if then you press and hold that large chip that's next to the squiggly antenna there, and maybe count to 10, or in fact, you can press and hold it and just repeatedly press the B button. So I've got my thumb over it and I'm up to 91.3 something. I just accidentally reset it. Press it again, 91.5 something. One more time, 93.5. But it's not going to go up to 98.5. And so this is a situation where you could have your students apply some extra math in their code to, it's a y equals mx plus b problem. And remind me to show you about that later. And all right. So that's that. Let's move on to the next one. Okay. So I'm going back to temperature sensor, I hope. Here we go. All right, next up is light sensor, which is just simply the LED array. And let's see here. Okay, so I believe that this one is the one I wanted to do. Okay, so let's open this one in Python, and I'll give you the link in a second here. That's a really long link. I'm going to give you a link to the page with the link because I don't know if that's too much text and will overload the Zoom. All right, there we go. So that'll take you to this page. And when you get here, click Python and then select Open in Python. And what they did was they set a threshold so that anytime you're over 100, we're going to light up the LED display. So let's see how we're doing with that. I'm not really sure how well I'll be able to demonstrate this one. Flash, so connect and flash. Okay, so I am currently, oh, look at that. Okay, I just happen to be in exactly the right place so that I've got a light next to my display. And when I actually go into the shadow of the display, the lights turn off, indicating that the lights are below a threshold. And then when I go out of the shadow of the display, so in theory, if you point it at a window, it should light up like this. And then if you put your hand over it, here we go. So like I got my hand over it, and that turns it off. So that is an example of the built-in light sensor, which is basically using the LED lights as light sensors. They can give off light if given current, and if they're not given current, they absorb light and give off current. So that's kind of a cool feature of LED lights. Let me know when you're all through with that. Give me a thumbs up. Okay. All right. I see. Okay. How you doing, Debbie? Oh, no. Sorry.
I don't know. It's not doing much when I cover my hand over it, but
try pointing it straight at your light, at the light in your room. Point the face of the LEDs straight at do you have an overhead light? Is it showing you anything when you do that? Okay.
no.
You may have kind of low light conditions.
Yeah, possibly.
Quick check then, does your code look like this?
Mm-hmm.
Okay. The other thing you can do is if you have a cell phone with a flashlight, you could get it up nice and close to it and it should turn on then.
I ran into the same thing in my living room here, Debbie. I don't have any lights on, but when I pointed towards my window, it then did work.
Yeah, the cell phone worked. So,
Oh, excellent. Okay.
yeah, the cell phone worked.
So Windows and cell phones are good, strong sources of light with lots of extra infrared in it. Well, no, the cell phone light is just a bright light.
Mhm.
Don't know whether it's got infrared or not. All right. So again, I'm just showing us all one example of many projects that use that particular building block. And of course, students can take it a lot further. All right, next is a fun one. We've got our compass here. And so again, just to make things go quickly, let's see here. Let's just do the compass bearer. No, actually, I'm going to, let me think what to do here. Let's just do the compass. Okay, so I'll open it and give you guys this link. Copy. Let's see, open, so Python. All right, just about got you the link here. Chat, paste. Okay, so there is the link, and now we can all open our Python project. And then connect if you're not connected, and then flash. And it'll quickly load the code. Now, it's going to start displaying a message once you've got the code loaded. So it's telling me basically to move the microbit around in every which possible direction because it needs to calibrate. So essentially a little three-dimensional infinity symbol or figure eight where you're twisting the microbit as you go through, and then it'll smile at you, except for mine did something funny. I'm going to restart it. Okay, so again, it's going to tell you to move your microbit around. And we may need to connect the batteries for this one if your USB cable is too short. There's a battery pack that's in your kit. So as soon as it starts showing a partially filled display, that's the time to move it around. And then it'll give you a smiley face when it's sensed every possible magnetic direction that you can give it. Okay. And then it's kind of difficult to do this because I need to have it flat to really sense direction, but that's 182 degrees, 190 some, 250. And so on. So you can see different. So I'll try to point it roughly north as I understand north in this building. Yeah, that's not very north. Anyway, you can keep on twisting it and checking the value. And one of those values should be close to 0 degrees or close to 360 degrees. And that means you'll be close to north as you have your microbit oriented in that direction. While you guys are doing that, I'm going to go, well, no, I'm going to wait till everybody's got that set up. So remember to see the measurements, you'll want to hit the A button to get the number of degrees. So I'm going to keep it flat, point it to where I think north is, and then hit the A button. I was still a little off.
I think my compass is in Celsius.
Let's see here, 175, 173. Try resetting and recalibrating. Also, you know, one of the things that can happen is there may be something strongly magnetic close by. Including your cable. Okay, let's try another option. Well, have you guys all got that running? Despite the fact that it might not be running spectacularly well. 175, looking good. Okay, so I want to show you something. And so again, you can use help to figure out what compass heading and display dot scroll and button A dot was pressed and while true. You can use help to find out what those are all about and go to documentation. And just a second, and I'm going to go to the direction category. And there's a program here that I want you to do that same routine with. It's on its way. Did I forget to, I think I might have forgotten to reshare my screen. Sorry about that. Okay, so quick repeat on that. Okay, so basically here we are, and there are some things that we might not know about, like compass calibrate or compass heading or STR display.scroll. All of those things are discussed in help documentation, which we talked about briefly during the previous session as well. So that's a nice review. There is the documentation page, and then going to the direction page and pasting that one in. All right. Now, so what I want you to do is grab this code and copy it, and then go back to the Python editor and Control A, Control V, or just basically select all and paste, and then flash that. And it will ask you to do the same thing of swinging your compass around until the LED matrix fills up. Okay, but this is pretty cool. It now gives you, and this one is correctly pointing, because north is basically pointing at my webcam, and it is faithfully pointing right at my webcam right now. I learned that one at a cyber.org workshop. Which we'll be talking about a little bit later. It's really, it was a lot of fun getting all our compasses going and everybody independently going to the north side of the room. Of course, since Ed's on Celsius, he might end up in the other corner.
So did you delete the other code, or did you leave it in there?
I just pasted over it, but you know, you can always, that's a good question. So to save your code in here, there's that load save button, and you can download the project hex before you make any changes. You can also just hit Control Z a bunch of times. So like here was the original code. I hit Control Z a couple times, and I could save that too. And then basically here now I'm going to drag my previous save onto the editor pane and see it updates to the modified code. Downloaded hex file, dropped on the pane, updated. Some of you may need to hit load save and then browse for a file and then go to your downloads in order to open it. It depends on whether you want to keep a copy or not. Thanks for asking, because I had forgotten to show you all that. And I hope I'm sharing my screen. Am I not sharing my screen again? Shucks. Okay, I'm going to repeat that. Share screen. So sorry. Okay, so so here we are with one version of the compass that shows a compass needle. Now, if I Control Z, I can get back to the previous one. And so we'll save that as compass bearing. Load save, download project hex. Okay, then I'll Control Y, or Control Shift Z maybe, or maybe cheat and grab the downloaded version I did earlier. So I want to change this one to compass needle. And then we'll go ahead and load save, download project hex. And then you can typically go between one and the other. So here is compass bearing. Here is compass needle. And I can do the same thing for my downloads. And when done, everybody got that? Can I see some needles? Okay, looking good. When you put it vertical, they all start dancing around, huh? All right.
So
Okay,
now
so
just remind me, when it's a straight line on that, it's supposed to be,
should be pointing north.
because it's different than the other code I put in.
Yeah, this one though, for me, it was correct at least.
Neither one was, well, this is a little, they're both a little off in my opinion, but I'm not
Okay.
sure.
Well, and that is a reality of a $20 device that can be a compass, temperature sensor, thermometer, display, button, radio, et cetera. I mean,
Yeah.
the things for it's still amazing, even though it's not overly accurate. And again, that leads to good challenges for the students in terms of adding some code that does some math to refine the measurements. And even provides a good motivator, really. All right. So back to projects. No. Okay, back to features. All right. See, I am getting concerned about the time. So do you mind if I just for now mention that there's a touch logo right there that you can use as a third button and leave those ones for you to try at your leisure? So I'd like to skip that one and we'll go to sound and at least make some sounds, because sound is well, important to a lot of people. So so let's go to sound projects and then we'll do jukebox with volume. Don't know if I meant. Sorry, one thing I did was I made a slide and then I decided that I wanted to here it is, jukebox. Decided to do it straight out of the page. Okay, so this is the jukebox and bear with me a second. So we're going to set this up for Python and then copy and then I'll give you the code for this to open. And paste. Okay. So it should now be in your chat to open. Now, frankly, these are kind of not the most exciting of songs. I'm going to reset that. Anyway, that's what you should get if you press button A, and button B will have a different song. Back to the help menu though. If you go to help documentation and then go to music, there's a nice list, like here's happy birthday. And now funeral's not exactly upbeat. Let's see here. I like wah, wah, wah. So I think I'll put happy birthday on A. And then going back to help. And then again, that was help and music. For the second one, I think I might do something nice and short like bading. Okay, so flash that. And then I'll hit button B. And then button A. Was that audible? Okay. And are you guys having similar results that I can't hear? Good. Okay, excellent. I'm gonna wait just another little while. Debbie and Ed, how are you doing? You good? Okay, excellent. All right, next topic, the mic. And now comes time to pay the piper because I didn't test this one. Microphone. All right, so I was wanting to do the sound meter. By the way, the microphone is very close to the touch sensor. Okay, open this a new tab. Oh, actually, a quick thing about sound. I noticed back in speaker, don't follow me on this one. Okay, so exploring sound projects. I'm going to open one in Make Code just to show you something. Okay, so if we go to Frere Jacques again, or Jukebox again, but this time I'm going to go to Make Code and open it in Make Code blocks. And again, this is just quickly to show you. If I load this code, or rather getting ready for this, I loaded this code and it didn't make any sound. And so that caused me to start hunting around. And see how there's this Microbit V2 blocks down here, and there's a set built-in speaker that defaults to off, which means that it doesn't make any sound when you try to run it unless you've wired a speaker to the thing like this. So in order to use the built-in speaker, you've got to set it to on. And then I think you may also have to add a on start block like so. So once you've got that going, then your A and B buttons will behave correctly. So it does it by default over here in the python.microbit.org, but in makecode.microbit.org, you've got to modify it. So that's a quick heads up. Just remember to do the on start and turn on the built-in speaker, and then everything works the same way it does over here as a default. All right, next up is the mic. Interested in the sound meter, so let's try it. Python. And now it's ready to paste to you guys. There you go. Hello. Okay. So there's not much sound right now, and I'm going to try whistling. Probably isn't going to work unless okay, so now it's showing you my voice because I'm speaking directly into the back of the microphone.
Hey, hey, hey. Hey, baby. Yo, yo, yo. What's up?
And by the way, the microphone, when it's running, has a little light underneath it that shows you it's kind of saturating the camera, but it does a credible shape of a microphone icon, the little light on the front. Okay, are we ready to move on? Looking good. Remember to shout at me if you need me to give you a minute. We're at the 1 hour mark. So one thing I'm going to need to do, I got a chat. Yeah, pretty neat. So this is not a full inventory of the features. Given the length of the workshop, I'm going to have to leave some of that exploring to you. And also granted, for every one feature, we tried one of anywhere between 6 and probably 20 projects, maybe 15, 10. So there's a lot more to try in each feature. And some of the things I'm unfortunately going to skip are, if we can get back to that. Okay, so I am going to skip over for now the radio. And if time permits, we'll get back to that. I guess I'll just show you that when you have more than one microbit, you can get them all on the radio, and you can load like a transmitter microbit into one project and then a receiver into another, receiver script into one, transmitter script into the other, or sometimes one transmitter and a whole lot of receivers. Why am I looking at, that's the microphone still. Where's the radio? There. Okay, so now we've got 17 projects. So like, remember the push button we did with a smile? Well, you can share that with a receiving microbit. The teleporting duck is too cool. You just tilt one microbit towards the other and the duck will teleport between microbits. I don't know if they have the Fireflies project in here, but that one is a lot of fun. Yeah, here it is. So when you've got a whole classroom full of microbits, the program has them coordinate when to light up and not over the radios. So there's just all kinds of really neat stuff that you can do with the built-in radio. But since we didn't send you 2 microbits, I'm also going to leave this to you for when you get your class pack. Students tend to like things like, hey, tell me a secret, and they can use their radio. I'm not actually sure if they set this to securely send the message. Let's take a look. Yeah, so they're reserving their own group. And so they are securely exchanging that message so that you can have, the first thing is you can start with students without this group configuration, and then you can have them each join a different group, and then note that they can pair, or 3 or 4, however many you want to have, having private communication about which button was pressed. So basically, you can hit the A button and send a check mark, or the B button, and I don't know what it sends. It might be an X. It's hard to say, but so that I'm skipping for now, but I really want you to try that, and there's more on that coming up in the presentation. So with no further ado, all right, so we just did some of the make it code it stuff. We did a whole bunch of example projects. But we did so by going through, and we talked about the microbit, so we did some projects, and now I wanted to talk with you about the Microbit.org lessons. Okay, chat, paste. We already did talk about these, so I'm not going to go into too much detail today. I just wanted to mention that there's a tremendous choice of lessons that have teaching materials to go with them. And so if we were to, I think a ways down, there's a computer science one that we talked about, and computer fundamentals. Let's see here. Yeah.
Just for the PLC, there's a cryptography and a cybersecurity one.
Yep. Okay. So here is cryptography. Here is cybersecurity. And cyber.org has an offering there too. But this is the one that is directly from the Microbit Education Foundation. And so here's the student materials, the lessons. And pardon me, you can download all the materials that surround this lesson. So it gives you a lesson plan. And then if I download the whole thing, try again, show in folder. So it gives you a slideshow and some Word docs, that being lesson plan and student handouts. Trying to get that into a folder. I should have just unzipped it. Here we go. Unzip, extract all. See what happens if I just paste them in. There we go. All right, so here, for example, is the slideshow opening up. I think my computer might be slowing down a little bit. So this would be the slideshow for your use. Here's a student handout on code cracking that is in a Word document. So it has some fun things on trying to figure out what the message really is for the students. And then there is a lesson plan for your use. So it's good stuff. And they have a number of topics that they're covering. So basically, it's going to come down to what's going to be useful for your classroom, but each one is going to have basically the same pattern of lessons and links. So that's at microbit.org/lessons. Now, computing fundamentals was the example I was going to zoom in on, but we looked at cryptography instead. So let's skip that in the interest of time. Now, we've been talking about make code versus make it coded. They're resources on the same website. They're both on microbit.org. It's just that sometimes there's a little bit of confusion. So we've been in the make it coded world because there's a focus there, at least on the main page, on projects. And so we were able to go and get some nice simple projects as starting points. And then each project does challenge you to expand it. And so that's a good maker approach to getting the students started into coding and getting them some enthusiasm. The examples are both in make code and then the python.microbit.org MicroPython. So make code is implicitly, you've got your choice of blocks, JavaScript, or Microsoft's version of MicroPython. And then what I call MicroPython is the microbit dot or python.microbit.org editor that is right there. So Make It Code It has features. That's where we looked at the all the hardware things like the thermometer and the compass and et cetera. Those were the features. And then the lessons, we were just in there. Classroom we did last time where we were all sharing our code in a group room that was on the web. So those are things that you'll find on Make It Code It. Now, Make Code is, primarily when I go to Make Code, I think of it as a programming environment, but there's so much more. So close all these tabs to the right. All right, so, whoopsie, I went to Make It Code It. Sorry about that. Let's try again. Oh, it's because I really did go to Make It Code It. I didn't use the wrong link. So you can, for example, start a project, give it a name, etc. We did that last time. There are tutorials like we went through doing with blocks, setting up our beating heart last time, and it showed you how to, make the LEDs and stuff. Now, some other things about Make Code, though, that, too bad I can't really get back with the back button. Exit tutorial. There we go. All right. There's actually a wealth of material here. So here is here are some things for the Microbit 2 that you can try out, as in it's using some of the features that come on the Microbit 2 as opposed to ones that are on all microbits. There's live coding, which is lots of coding videos. There's games. And so if this is where I wanted to talk about, if your students already have experience with, Ed, can you call that out for me? I'm blanking on the name. Is it arcade.makecode.org?
You're talking about the Make Code Arcade?
Yes.
Yeah.
Yeah, Ed pointed this out to me, that if your students have experience with this,
Yeah.
that they can make some little games on the microbit as well, because it's essentially the same coding, and it's the same block coding interface for that. And there's even radio games, which is amazing. Now, and then fashion, there's all kinds of interesting stuff. But if we pass all this up for a second and just keep going down, and the list goes on and on and on, we get to courses. And this is where your curriculum stuff comes into play. So I'm going to open Intro to CS Online, and I'm also going to open Intro to CS Classroom because they're different. Okay, so here is Intro to CS, your student manual. And so for conditionals, it's going to take you through some lessons. But if you go to Intro to CS Education Edition and look at the complete course package, so this right here is a 1.4 gigabyte download that I'm going to cancel. Okay, so there's 1.4 gigs of Intro to CS slideshows, handouts, teachers' guides, etc., that you can get to, and then it breaks it out individually here. So, for example, in conditionals, oh, I'm sorry, I haven't been pasting you the links. So here is the conditionals light version coming up. And then here is the educator, or I'm sorry, it shouldn't be conditionals. I meant to just do the whole thing. Sorry. Let's see here. So CS Classroom. So here we are in Educator Edition. So I'll paste that one in first. And then going back to Intro to CS Online is this one. All right, so those are two separate links. It's the same basic subject, but the Educator Edition, CS Classroom, has everything: slideshows, teacher's guide, student workbook, a quick start video. It's very complete. And so you can download the whole 1.4 gig package. You can access these individually. It's a kind of ginormous, humongous resource. Now, there's more where that is, like science experiments. If we look at the science experiments, I noticed a little side thing about the science experiments is that if we look at the entire course, I think it's going to show standards alignments. It also takes it a while to compile it. Let's see how long it's going to take. All right, I need to talk about something else while we're waiting for that one to compile. So courses, from the makecode.microbit.org standpoint, Make It Code It and First Steps. So we were at First Steps last Monday. This is actually where we started. So that's listed in the courses, as is Make It Code It. So there we go back. And so from the Make Code standpoint, Make It Code It is a course. Another one of great interest, once you get more than one microbit, is to go and do the radio communication tutorials. So here's the front page of the book of radio communication tutorials for Python. I should back up and just give it to you for the whole thing. Copy link, paste, and then I'll give you this front page of the. So the important thing is when you get here, if you want to start with the textbook, make sure to click the book page link, and that'll take you to the front page. It can be a little bit confusing if you're not familiar with GitHub and you end up in the GitHub repository where people collaborate on developing stuff. So this is the front page of the book. And for example, it's really great. They start connecting the microbits with alligator clips and doing wired communication before switching to wireless communication. And then there's lots of background information along with the code examples. So just fantastic material. Let's see how we're doing on the, we're still compiling the full resources for the science curriculum. The list just goes on and on. There's so much here in the way of curriculum. And a great deal of this has very nicely pre-compiled teacher resources, and especially, of course, the computer science classroom edition. That's really a star. The science experiments, I'm really hoping it finishes compiling here at some point. I noticed that here we are. Okay, so and now I don't see what I noticed the first time. Let's see if I can find this. There should be a link in this that that shows the standards. And here we are, the Utah Coding Project. So this was developed with the Utah Coding Project, and the standards alignments is somewhat Utah-centric, so it might be worth a look. I don't know if it'll apply to any of your classes, but it seemed like a good one. if not just to take and use, at least to amend other projects or other things microbit wise that you might have. All right. So that is where the curricula lives, is further down. It says courses, and it's it's quite a ways down the page. So just make sure to look for courses, and you will basically find a veritable gold mine of courses with teacher's guides, slideshows, standards alignments, the whole ball of wax. There, most of these have a really good offering of resources. All right, how are we doing for time? It looks like we've got 40 minutes left. Let's take a second just to see if there's any questions that came up, or if there's anything you wanted to take a little bit closer look at before I move on. I hope that was enough in terms of showing, well, you know what? Okay. If none of you have questions, if you do, give me a shout out. But if you don't, going back to the computer science lessons, the Educator Edition, classroom presentation. Just to give you an idea of the completeness of some of them. So it's got your slideshow for the classroom. Then here's the educator's guide. That's in a Word doc. So 23 pages for that section, for basically that week. And it talks about the different things that, so here's it's basically the textbook, but with the educator notes. Should hopefully look rather familiar. The student workbook and a quick start video. So these are things where, so this is the student workbook without the teacher notes. And so it's all here, and this is for 1 week in the term. Just really, really neat stuff. Lots of good material. And all again in makecode.microbit.org courses. Are we good? All righty. Next up is talking a little bit about the parallax contribution, which again, I mentioned this on the first session. It's a little higher up. So we're basically assuming that a lot of stuff has been done with the microbit. Well, not entirely. I shouldn't say that, because we have a get started, but basically this does add another layer that can be interesting to some students. And so the first example I wanted to show you is the Cyberbot. And I'm going to come back around because there's a lot of robot free, as in you don't need the Cyberbot to run them, lessons with teacher materials. So just a quick overview of the Cyberbot. We've got our microbit here, and that microbit gets attached to a larger board that you can build circuits on, and you can connect servos to, and it makes the wheels turn once you program it to do so. So here's an example of something we do early on that is relevant to coding, but it's from a different angle. And you'll see in a minute how it's potentially interesting to be able to add a physical aspect to code that is beyond the microbit as kind of a microcosm of a cell phone. So here we have the microbit as the coordinator of a robot. And so these are statements in Python for making the Cyberbot go straight. So basically you set a couple of wheel speeds, and they do have to turn in opposite directions to make the robot go forward. because the servos are pointing in opposite directions. And then sleep 4,000 will make it do that maneuver for 4 seconds. Then this is a turn in place maneuver, which we do for just over 1 second. And so you get a forward, and then you get a turn in place, and you can tune these numbers here so that it's really close to 90 degrees. Now, after you've done that, hey, let's introduce our friend, the for loop, which when you put statements below and indented from it, will execute all those statements a certain number of times, in this case, 4 times. And lo and behold, we just went from forward and left turn and stop to 4 forward and left turns and stops for a nice little square. So that's kind of the added interest of having a robot. There's a few other things, or there's a lot of other things that we have in the kit. For example, little sensors, little contact sensor circuits, so that when the robot bumps into something, it will detect that it has done so, and then your script can make it turn. It can also sense light and follow it. And it even has little infrared flashlights and sensors that allow it to send out infrared. It bounces back, hits the sensor, and so the robot doesn't even need to bump into the obstacle. And then, of course, I don't remember if I showed this last time. It's just really too cool. By using the built-in radios of the Microbit, you can type in basically some of those maneuvers that we just talked about. You can type those right into a terminal where one microbit is connected, and then that microbit sends out to the microbits on all the robots, and then they have scripts that receive the commands and parse them and execute the maneuvers. So curriculum-wise, now, here's where we come back to, you can use a lot of this even if you just have a microbit. And there's also kind of another neat thing about this, which is, let's take a look at writing microbit programs. That's one of the things you can do. Some of you may want to do a more conventional textbook / tutorial type of thing, where maybe on the left side of the screen, you've got your tutorial, and maybe on the right side of the screen, you've got the editor. Here's python.microbit.org again. And so here's the tutorial on remembering and using values. And it's basically just declaring variables and storing them, and then displaying them with the with just this this little display on the microbit. Solve math problems. It's just basically doing a math problem and displaying the result. Very simple. Here, I'll paste this one into the chat for you. Chat, paste. And so if you copy and paste that into your python.microbit.org editor, make sure you're connected. And so you'll, oh, you know what? I didn't properly copy and paste. Copy, paste. There we go. That looks right. Connect and flash. Okay, and then I'll see the solution to 89 plus 42, but I missed it. Have to hit reset on the microbit. A plus B equals 131. Hmm, 121 it should have been. A plus B equals 1. Yeah, that. Ah, yes, that's right. I forgot to carry a 1. Yeah, so it is 131. All right, folks. So this is a more conventional way of going through a tutorial, and it's got your next page and previous page. So making decisions is next, and you learn about, type in a script. So, and for best results, definitely, actually hand copy what you see on the left, and then that'll get it into your mind in a more permanent way than simply copying and pasting and trying to read and understand. We also use try this and your turn to challenge the students in different ways to put their hands on the keyboard. Now, going back to, that was one tile on the tutorial series page for the Cyberbot. There's a lot of tutorials on that page. And so one thing I did on this slide was I set up, I listed all of the lessons that are available on the Parallax Cyberbot pages that you can do with just a microbit. So this is yet another example. And the one I'm going to have you guys try out, hopefully, is display tilt direction, where first we do a clock using that little needle that you saw in the compass. And then, let's see here. I guess I linked to the wrong thing here. I'll have to fix that afterwards. Okay, this is unfortunate. I'm sorry about this. Let's see here. I grabbed the wrong thing, so I want to see if I can find somewhere where it shows you, where's the script? Here are tilt tests. Yeah, so this is the one I wanted to show you. And is this really, this is just printing it, unfortunately. Oh, darn it. Well, all right, so let's run this one just to see. So here is a video clip of actually using a radio and tilting one microbit and seeing that same, and the needle is basically pointing in the direction a ball bearing would roll off the surface as you tilt it. And so that's also displaying on a receiving microbit. But for this, I'll just go ahead and have us try out this one right here. Okay, so chat, paste. Okay, so there is test tilt intro, and you're going to need to paste it in, but it's not going to actually do what you see on that video clip because I messed up and didn't get the right link, and it's been so long since I wrote that stuff. I'm not remembering where it is at the moment. So I'll just show you briefly. If you paste in the code and load it into your microbit, that so this is going to be a review of Open Serial. So after flashing the code in, hit Open Serial. And then you can try rotating your microbit gradually in a circle. So for example, as I'm holding it with the USB cable pointing up, my Y is 1048 and my X is -16. Now, if I hold it pointing sideways, note that now X is in the neighborhood of -1024. If I point it the other way, X will be in the neighborhood of +1024. And there is a continuum as you rotate it. And if there's any math nerds in the room, there's some additional lessons in the accelerometer stuff. Measure rotation angles. So what we're doing here is figuring out how far we have, so we're taking that X and Y, and we're actually going to use a little bit of trigonometry to figure out that since they were equal, I must have rotated it at a 45-degree angle. So that's some higher level stuff, but it's there. Want to make sure you know about it. Then as far as the teacher materials, they are at learn.parallax.com/ I believe educators. Yes. Okay, so I'll paste you guys this link. Okay, that's learn.parallax.com/ educators. And I'll go into Cyberbot Resources and paste you that link. And then this is the part where we signed all of you up for an account at learn.parallax.com. Because sure, there's teaching strategy guides, slides, standards matrix, scope and sequence, all that stuff is visible, but pardon me, but you've got to log in to get the assessment materials. And so that's this logged in link. Okay. So going back to educators and Cyberbot Resources, now there's an assessment material download. And here's all the assessment material for the Cyberbot, and you can use these to make, it's basically solved material for, or, it's the material and then the solved version for you. And so let's see here. Let's do Nava. Since I want to pick one that you'll be likely to use. So here's the full zip, but writing programs is one that you would be likely to use. So downloading that. Extract all. And nothing comes up when I do that. So basically we make a PDF and a Word doc of the assessment material for any given section. And so I'll go ahead and open the PDF. And so it's a basic handout, and just be careful because you only want to print up to a point since the answer key is below the actual student handout. So that's an example of some of the resources that we've got here at learn.parallax.com. The Cyberbot due diligence, if you want to buy one, here's a link to the various different options. Paste. Let's see, and then yeah, Cyberbot Educator Cyberbot Resources. Then there's the Cyberbot. Next up, with 20 minutes to go, is cyber.org. Are there any questions before we move on to that?
No questions, but here, I believe, let's see, Kurt's got one or two of the Cyberbots, and if I'm not mistaken, Jerry Crozman has one. And I think I have one in my office too.
Okay, you know, I mean, even if you're not going to do the whole Cyberbot thing, just showing your kids your Cyberbot with a program running is fun. And there's a whole bunch of example programs in the student pages. I should really show you that. Thanks for mentioning it. Okay, so going back to the Cyberbot tutorial series, let's say that you want to make your Cyberbot tilt controlled. So you want to tilt a microbit and have your Cyberbot respond to the microbit's tilt. This one's on batteries, by the way. Usually, now you don't necessarily have to go through the whole tutorial. There should be, gonna log out here. Oh, darn. Okay. There should be code at the end that you can load in for the controller, or pardon me, for the controller. Here's the Python for the controller. And then here is the Python for the controlled robot. Whoopsie. And so basically you can load and go without necessarily having to go through this. I don't know, I would guess it's a 50-page tutorial if it were in a textbook, 50-page chapter. So you can either, so that's, there's lots of different opportunities for loading something into your Cyberbot robot to be able to show to your students the infrared navigation, the visible light navigation, all of those. You can just simply find the end where you're navigating by light and here it is. So this is where we're making some shady decisions about where to make your robot go. So if you wanted your robot to follow some light, you would just go near the end of the chapter and you're going to have the full script without the steps leading up to it. And in most cases that works out okay. There's not usually much in the way of critical calibration that you have to do. The one exception to that is in the in putting it together, you've got to make sure to calibrate the servos. I believe that's in, it's either in navigation or build your Cyberbot. Yeah, here it is. Are the servos centered? So you have to plug it in, run a script, and then use a screwdriver to make sure that the servos stay still while the script is running. So let's see if, so this is showing how to run the script, but eventually they'll get to, there's a hole in the motor, it's turning slowly, and so they stick the screwdriver in and they adjust the little Phillips head potentiometer that's in there to make the servo stay still. So that's a crucial step before any of these other programs are going to work. So I will paste this one in, copy, paste, very crucial step. But aside from that, all the rest of it, you can usually go to the end of a given chapter and find the script that makes it do what was in the YouTube video at the beginning of the chapter. Okay, cyber.org. They have a similar, well, no, cyber.org has another vast collection that is broader in scope than, no, it's because the Microsoft MakeCode classes list we looked at was pretty broad in scope too. This is set up for USA classrooms. And this link will only work if you've got a login. My login is already in my browser, so it automatically logged me in. And so some of the places where you can get curriculum would be cyber literacy. And so that they do something similar with the Cyberbot, where there are going to be some example programs in here that are, will run straight off the microbit. Let's see here. There is also, back to courses, coding fundamentals. This is a microbit only course. So you can do make code block or Python. I've been leaning towards Python, but we'll continue with Python. And so again, you've got your master notes for the teacher, your source code, worksheets for the students, and so that's coding fundamentals, but notice that they've also added some cybersecurity material here. So here, I'll go ahead and paste that in. You'll have to log in to get to this, but it's a great resource. There we go. And in the slideshow, which you all should have the link, I emailed it out and can do so again as a repeat if you think it's going to be necessary. In the slides, I put links to the courses that are listed that use microbits that are in cyber.org. But heck, it's really worth looking around. I mean, they've got some awesome other courses, some of which might fit into other classes you're teaching. So that is, give that a look. Is there any question? I know a number of you are using this. So if anybody would like to comment on what they're doing with their classes and how they're using it, we'd love to hear from you. No takers right now? Because I know a couple of you are using it. Go ahead.
I've been using the cyber.org with a for school club. They don't have like any kind of PowerPoints to go through presentations. A lot of their stuff is kind of like, here's what you're doing, and then here's an example piece of code, and then it's like, okay, go do it. So you might want to make sure that you definitely look the lessons over ahead of time and have some kind of background stuff to be able to introduce to the students if you're going to use their materials.
Thank you. Those are words to the wise, and we, I hope, have sufficiently covered background material and where to find it in these two sessions. I don't know. Are you guys? I hope you guys are feeling confident that you can find resources now for the microbit. Okay, excellent. Okay, so yeah, as Kurt commented, some of these might be kind of sparse. Let's take a look a little closer in coding fundamentals. So I'll just close everything to the right. And then we'll open. Okay, so it looks like Compass.
For example, we just did the animation, so lesson 4.
Okay.
And the problem that we were having was the kids were trying to copy and paste the source code, and apparently the quotation marks weren't copying correctly.
Yeah, I can see that they wouldn't, because basically right here, yeah, these quotes need to be fixed. I can put that in a note to cyber.org. I'm just going to put it in the text. So Andy, reminder. Quotes in animation, wrong character. Okay, good. So when I'm going through the chat, I'll grab that out and send them a little heads up about that. And so, yeah, that would be a thing where you'd need to basically search and replace all these quotes. Okay, very good point. Yeah, so in that lesson, we have master notes and source code. Some of these do have worksheets as well as master notes and source code. So this looks like it's the compass and comparisons. And so, so these are, have a little bit more material. And so it's something where they have the unfilled worksheet and then the answered worksheet. So be careful again about that. And I do see how it's sparse, and I think that's going to vary with the course. So each one is going to have different authors. So definitely do go over it ahead of time, but it is another place that you can get lessons for the microbit. And they also have lessons, as I mentioned, for a wider variety of things. They've got their cybersecurity curriculum, IT fundamentals, some science like the physics, more science. So yeah, lots of good stuff in here. A+ certification, more math, etc. So another place where you can find microbit material. And you guys are all signed up for that. Let's see, we've got 9 minutes, 8 minutes left. Okay, so the last thing I just wanted to show you quickly is another thing where you can extend your microbit. If you notice that it has a whole lot of little these little plated pads right here. There's quite a few of them. And what you're seeing when I reshare the screen is a little adapter that you can plug in. And what it does is it takes all those plated pads that are connected to the microbit's controller, and it allows you to use them on a breadboard. And so the kit comes like this, and then you end up, after working on it for a while, you have a rather large application circuit built up. So this is a kind of electrical and electronic prototyping playground here. This is a ever-growing list of tutorials for it. And I'll paste this into your okay, so there's here is the parallax books for this, and these are very carefully guided tours. So let's look at breadboard setup and testing, and here is the link I just followed, and then breadboard setup and testing we'll do too. All right, so as an example here with breadboard setup and testing, the documentation, I really put a lot of effort into this because it's very close to home for me in that I want, well, basically I had this experience when I was a youngster where I was in a convenience store in University Town, Davis, California, and some grad student was talking about robots he was building. And I ran up to him and said, "Hey, mister, can you show me how to do robotics?" And he literally gave me the brush off, get lost kid. And that left a big impression on me. So part of my life's mission has been to make sure that everybody can get to learn the cool high-tech stuff. And electronics is a place where they skip a lot of steps when they're showing you stuff and how it works. So hopefully these examples are the kind of thing where you can see that we're putting a lot of effort into making sure that every single step is documented, like orienting your breadboard properly before lining up the adapter for the microbit with the breadboard, and really looking close to make sure you get it right. And then also, since I happen to be rather familiar with mistakes students make, showing them, make sure those pins sink all the way into the breadboard. Was that visible, by the way? Did you see could you see the pins? Okay, good. So, so this is something that I've been working on as an extension to the microbit. And there's a lot of material here. A certain amount of it may be outside the scope of middle school, but there are definitely things that you can pick and choose to have middle school students enjoy themselves and learn a few things. Let's see, first breadboard circuit is another one I wanted to show you. So let's see here, build and test the light circuit. All right, so what we're showing here is that I'm going to wait, or actually instead of, I'll do this full size. So for teacher resources, I have this full size version that you can pause. That's an MP4 that you can play. And so what we're showing you here is you're starting with a part called a resistor, a part called a light emitting diode, and a wire. And then you've already, to get to this point, you've already followed a number of other instructions. And so here, what we're doing is we're showing, okay, this wire is going to disappear. It's going to appear over there in a socket next to the blue line, and a little ground schematic connection is going to appear on the circuit schematic. So here's ground, and then here's a little wire connecting this, which was introduced as ground earlier. And so this is kind of, we're at an intermediate spot, but we're showing the relationship of circuits to schematics. And so then we go ahead and put the LED in, and it shows, look, this is what the LED looks like in the schematic. And then here is what it looks like with its longer pin on that side in the actual circuit. And then we continue with the resistor dropping in. Now, at this point, the resistor is sticking up into space, and likewise, there's no power connection to the resistor. But then eventually, we have the power connection with our 3 volts and our resistor going in there. So I really went to great pains to make sure that this is something that students can succeed with. And I'm hoping that over time, more people get to start working with it, especially after they've used the microbit in other things. Using it as a lesson to pre-engineering and electronics is kind of a good thing. Electrical measurements, just as another example. Whoopsie. Back. All right. Now, electrical measurements is where it gets a little bit more advanced. For example, when I'm talking about measurement units, we're doing some of the stuff that you learn in basic chemistry and physics, where you have a metric prefix and an SI unit. And I actually have some chalkboard type material in here where it shows how to do the math to make a conversion, both in textbook style, and then also I just put a little digital whiteboard on here to show, okay, well, if you have a problem like converting 1K omega, or pardon me, 2000 omega or ohms to, what would that be in kilo ohms? This is the way to solve it. And again, I'm jumping through various little pieces of this just to show you that it's a potential learning experience for students. And we have lights, push buttons. And then in the more advanced area, we've got your servo here, and it talks about how signals work and how the signal that's sent to the servo determines where its little armature turns. And what's really neat is I did some software for this called the Cyberscope, where you can actually measure those same signals with the microbit as it's running the servos, and even learn about the names of the different parts of the signals that control a servo's motion. So that's a little blurb on the microbit, and it has the same kind of teacher resource. It actually has a little bit more than the Cyberbot does in terms of teacher resources, because there's teacher's guide material. There is, and again, that's also on learn.parallax.com. So learn.parallax.com, educators. Here we are. What's a microcontroller? And then I logged out. You can log in again to get to the material, but we're almost out of time. Nope, we're 18 seconds out of time. So I'll paste that one in. And let's see if there's anything that I totally neglected here. Educator Resources. So this link is to all things microbit at Parallax. It's a good ending link. in case you need to purchase anything. Here's all our social media channels. And folks, I want to thank you for coming today. All right. Any open discussion before we, is there anything that any of you, I'd like to capture as much discussion as possible before I stop the recording. So if anybody has any comments or additional questions that we can put up, because I surely skipped something.
So Andy, there are just so many resources. I'm just trying to figure out where to go next.
That is the part that I could not presume to answer for you in these two workshops.
Yeah.
It's the kind of thing where now you know where they all are, kind of what they are, kind of how they work. And so pick something that looks attractive to you and start digging in. That's what I'd have to do for myself too, because I cannot really prescribe, because another thing is that each of your classes and students, some of the students may respond better to the make code approach of starting with partially solved things and improving them. Others may need that guided walkthrough step by step. Hi, Chantel. Oh no, just go ahead and
If you could call Rosa.
okay. Oh yes. All righty. Will do. Thanks.
Thank you.
So, so yeah, the other students might respond better to the make code walkthrough and debugging. And then the same applies with which class. Do you want to do the computer science through the Microsoft site or through the Make It Code It site? Both have slightly different approaches. And so those are going to be places where just pick something that looks attractive, dig into it. And if it's not as good as it looked, then try the next thing. And once you find something that's working well, use it, share it with your colleagues.
Sounds great. Thank you.
Okay. Yeah, that's the best I got for you. Otherwise we could do, we could do maybe a 10-week version. Okay. Anybody else?
Steve, we do have some follow-up coming, okay? Some other trainings that will hopefully help lead you in a direction.
So guidance as opposed to generalist here.
Well, being familiar with the microbit is you have to know what you're working with before you can move forward, really, right?
Yeah, we covered a lot. We covered the microbit basics, getting started, features, resources, platforms, and then curricula. So that's a lot to chew.
Absorb.
But, yeah, absorb. But I do hope especially that just the extra work with loading code using the different systems is going to be something that will, help keep your class more manageable when you implement it. All right, then. Shall I stop the recording at this point?
Anybody have any last things? Anything?
Well, it's just in my experience, I've generally kind of taught the students the basic kind of steps on how to do it. And I really like how you went through the temperature and the lighting and the microphone and like all of that. And what I've done in the past is I've done like 4 or 5 kind of simple projects and have them do it. And then I say, okay, you make a program based on everything that we've done, and you come up with some simple application. And typically, like Steve, I would give them examples and say, maybe you're an umpire, like we'll do the scorekeeper, and they'll have 2 variables that keep track of the score for 2 teams. And I'm like, maybe you're an umpire and you want to keep track of balls and strikes. And so you just take the scorekeeper and you change it. So instead, when you get 4 for one side, then they walk. You get 3 for the other side, then it's an out. And then you take it a step further, start counting the outs and when do we switch innings and things like that. So it's just giving them kind of some introduction and learning them how to use it, and then saying, okay, you guys figure something out, that practical application that you could use it for.
Yeah, so for example, that might launch partially off the countdown timer where they press a button to increase the level from which they start counting down. We didn't do that application, but it's one of the many, many in there. And so, yeah, just to build on what Kurt said, you've got a number of nice, simple elemental solved examples that you can show the students, and then they can start putting things together to make their own inventions or an invention that you prescribe, depending on what you think is going to work the best. And be careful about their own inventions, because students tend to really not think about how difficult something's going to be. They just think it's going to be really cool, So I, if you let them come up with something, maybe get a little Socratic about what it's going to involve before they commit to whatever it is they're going to do.
Well, but on the other point is, if you let them try it, because remember, in coding, you're never going to do it right the first time. It just doesn't happen, right?
Nope, it doesn't
so
happen.
If they take something that's too big, you might advise them and say, well, it's pretty big, it's going to take a lot of work, but if they're adamant about doing it, let them do it, because what's the worst that they're going to do? Not finish it?
Well, and another thing there is to help them. I would suggest having them proof out, try to separate it into little pieces and proof out each little piece, and then start integrating them into a bigger program one at a time. I know the biggest mistake I made when I was in 9th grade in my first programming class was that, I spent the entire class period writing this giant program. And then of course I spent the rest of the next 4 class periods that week debugging it. And so subsystem isolation and getting each little thing working and then starting to put them together is going to help.
But again, you think about the learning you're giving them, right? In your case, Andy, that program, the end product that you were looking at getting, think how much you learned in getting to that product.
Suffering was a very stern teacher.
You debugging, you compartmentalized, you modularized your program. And those are all key elements to so much. And so that's my point, is advise them and try to get them to understand that this is going to take some time. It's going to take some work. You might want to try something, right? Use your adult mode. I hate using that, but because if a student, if they want to do it, let them do it. Because
wanting to do it is just the best motivator for learning.
It might be just because they may put in a lot of extra hours that they're willing to do, because they want to show you that they did it.
Yep.
And again, what's the worst that happens? They don't finish it. It's the learning process, right?
Yep.
And
yes,
so
it is.
Be temperamental on that, because if they're really set on doing it, just help them along, and don't do it for them, but help them along with it. That's what I would recommend.
That sounds, I'll take it. And I think you're going to go further with the group along those lines, I'm guessing, coming up. Okay. Yeah.
Well,
Great
Andy,
stuff.
thank you for your time. Appreciate it.
Thank you. It's been a great pleasure working with you guys, and we will eventually get the YouTube videos up when somebody with the keys to YouTube comes back. Everybody's out right now, but they should be back within a week or two, and we'll have it up. And I will share it with Ed, and I think he's going to, Ed, are you going to put it on a private spot until we can get it on YouTube?
Yeah, I'll make it available to everyone so they'll have access to them as well.
Excellente. All right. Well, thanks, everyone. And I'm going to go ahead and stop the recording now.
All right. Thank you.
All right.